UDP works a bit differently from TCP. When you send data via TCP, you first create a connection. Once the TCP connection is established, TCP guarantees that your data arrives at the other end, or it will tell you that an error occurred. UDP is a connectionless protocol that does not create a connection between the source and the destination. Instead, it delivers the packets as soon as they are received. With UDP, you just send packets of data to some IP address on the network. You have no guarantee that the data will arrive. You also have no guarantee about the order which UDP packets arrive in at the receiver. This means that UDP has less protocol overhead than TCP. If multiple UDP packets arrive at a destination, all of them must wait in a queue before all their preceding packets are processed. Because of this, it strictly processes one packet at a time. The application program using the services of UDP must fulfill all these additional requirements. In multimedia transmissions or voice transport, transmission speed is a greater concern than accurate delivery of the message itself. You want the signal to arrive at the clients as close to life as possible. Therefore, if a frame or two are lost, you don't really care. You don't want the live broadcast to be delayed just to make sure all frames are shown at the client. UDP is never used for transmitting critical data. Java's implementation of UDP is split into two classes, datagram packet and datagram socket. The datagram packet class stuffs bytes of data into UDP packets called datagrams and lets you unstuff datagrams that you receive. A datagram socket sends as well as receives UDP datagrams. To send data, you put the data in a datagram packet and send the packet using a datagram socket. To receive data, you take a datagram packet object from a datagram socket and then inspect the contents of the packet. The sockets themselves are very simple. In UDP, everything about a datagram, including the address to which is directed, is included in the packet itself. The socket only needs to know the local port on which to listen or send. As I said before, UDP doesn't have any notion of a unique connection between two hosts. One socket sends and receives all data directed to or from a port without any concern for who the remote host is. A single datagram socket can send data to and receive data from many independent hosts. TCP sockets treat a network connection as a stream. You send and receive data with input and output streams that you get from the socket. UDP doesn't support this. You always work with individual datagram packets. All the data you stuff into a single datagram is sent as a single packet and it either received or lost as a group. One packet is not necessarily related to the next. Given two packets, there is no way to determine which packet was sent first and which was sent second. Instead of the orderly queue of data that's necessary for a stream, datagrams try to crowd into the recipient as quickly as possible.